Hello everyone, here we are. Let me run the introductory video and we are good to So, hello everyone. Here we are with yet another exciting PD with GEG Punjab, and today we have Dawn with us. Dawn, why don't you take up and say something about what you're going to, show us today and what we are going to take over?
Hi, everyone. Thank you, Dr. Narjeet, for inviting me today to the GEG Punjab. I'm really excited about presenting to your colleagues today. We're going to have some fun, and I'm really excited to hear any feedback folks have. Before I get started, my prayers and thoughts go out to you all because I know you're suffering through some of the challenges with COVID. We've had similar challenges, and I know it's a tough thing that we're all going through. It's affecting friends and families and our work and our lives as well. It's kind of a pain in the neck to have to be stuck inside all the time, and it's no fun. So I'm hoping and I'm praying that you guys get through it quickly and that we come out of the other end of this all happy and healthy and safe.
Yeah, so we have Dawn and we are going to have a very exciting session. I hope our maths teachers are going to get a few gem takeaways from today's session and they will stop complaining about how to present in the class. Ma'am, how to write formulas, how to draw graphs, how to present, and how to make it interesting. Because math is something that really requires a lot of effort on the part of the teachers to make it interesting to the students. They do not get hooked on to mathematics very easily. So, yeah, Dawn, all over to you. And yeah, we start with the presentation.
Well, Dr. Narjeet, thank you so very much. I really appreciate it. A little background just before I jump into showing you what Math Whiteboard is all about. Math Whiteboard has its origins in some PhD thesis work that was done at Brown University. I did my PhD in computer science at Brown, and my team, we all did our graduate work in computer science at Brown. The work was done in a research lab that in general focuses on graphics and user interface technology and at times at educational technology. And this work came out of some, the Math Whiteboard and its technology came out of some research that was done in that research lab. A couple of other things before I jump into it. Math Whiteboard is a free system. It's also barrier-free. I call it barrier-free, meaning that it has no logins, no passwords, no subscriptions, and it's no accounts or anything. So it's just a website that you go and you use. The other thing I should mention before I jump into things, you'll see that I am going to be writing a lot on my screen with a stylus and with my finger. And I know that not everyone has a touchscreen device, and you know that as well. In fact, the majority of our users do not have touchscreen devices. In fact, I think a lot of our users are using Chromebooks that just have keyboard interface, and that's great. Everything I'm doing with a stylus and my finger on the screen, you can also do just as effectively with a keyboard and a mouse. And I'll show you the keyboard and mouse interface as well. It works really well. So why don't I jump in and show you what Math Whiteboard is all about. So I'm going to share my screen, and Dr. Narjeet, I'm going to ask you, because my face often gets very close to the screen because I'm writing on it with my finger, I'm going to ask you to turn off my camera because it might look a little strange to see my face so close up.
I'll do that. Don't worry,
great.
I'll do that.
Awesome. Thank you very much. So let me share my screen, and we'll jump into it. Okay, click share here. I'll share my screen, and I will click on share screen. Okay, so we should now be seeing my screen, and I am going to just dismiss this browser window. And So I have on the screen here, the reason I have two web pages, two web browsers on the screen is not because I want to advertise Math Whiteboard twice as much. It's instead because I'm going to be showing you how Math Whiteboard can be shared synchronously between users, and I'll use two browser windows to demonstrate that. But let me dismiss one of them to start with, and I'm going to expand the other one so that we can see it full screen. And I'm going to open up a Math Whiteboard here. So let me start a Math Whiteboard. So one other thing I should mention before I jump in is that Math Whiteboard, again, runs in a browser. So it will run on any type of device, whether it's a Windows device. I happen to be using a Windows tablet. It runs on Chromebooks or iPads or MacBooks. Really, it'll run anywhere. So let me jump in and show you what Math Whiteboard is all about. So think of Math Whiteboard as like a smart piece of math paper. For example, I can write some math. 1 plus 2. That's pretty simple math, but you'll see it recognizes what I write, and I can get an answer. 1 plus 2 is 3. I can change the math, and the answer will update dynamically. I can change this 2 over here again to a 3, and the answer updates dynamically. I can change the 3 to an A, and then I can assign a value to A. So when A is equal to 1, A plus 2 is equal to 3. I can change the assignment to A to a 2 maybe, and then the answer A plus 2 updates dynamically. I can change this 2 over here to a B, and then I can assign a value to B. So I can make B equal to 3. So A plus B, when A is equal to 2 and B is equal to 3, is 5. I can write more math on the page, maybe A minus B, or A times B, or A over B, and I can get answers for all of these math expressions as well. Now, when I go back and I change the value assigned to A from a 2 to a 6, all of the answers on the page update dynamically. Oh, and by the way, underneath the hood, we have a very powerful computer algebra system that allows me to do what you've seen so far is some simple numeric arithmetic and algebraic arithmetic. I can also do some more advanced mathematics. So, for example, I can write a definite integral on the page, and we can solve that as well. Now, when I go back and I change the value assigned to A from a 6 to maybe a 5, again, all the answers on the page update dynamically. Or if I change B to a 7, all the answers on the page update dynamically. I can even assign to A an expression like x plus 1, and now x plus 1 substitutes for A across the page. So if you're a math teacher or math educator, you know that learning mathematics is about seeing connections between things. Here, we're looking at the relationship between A and B with respect to some operators, plus, minus, divide, and so forth. In algebraic topics, we look to see connections between other types of things like algebraic expressions and graphs and tables. So let's take a look at a math expression that we're all familiar with. This is y equals mx plus b. This is the slope-intercept form of a line equation. I've written it on the page. It recognized what I wrote. With a simple gesture, I can make a graph. I'll do that again. So with a simple stroke of my pen, a gesture, a swoop, really, from this math expression out into some other area on the page, we can see a graph. I can pinch and zoom. I'm pinching and zooming the graph with my fingers. And if you're a math teacher, you know by looking at the graph and looking at the plot on the graph that we have selected default values for m and b of 1 because the graph has a slope of 1 and a y-intercept of 1. But I can change that. I can make m equal to a different value, like 2. And now we can see the graph updating dynamically. Or I can make m equal to 3. And again, the graph will update dynamically. I can be more interactive by creating a slider for m. And now I can show very visually what slope really represents. What is slope? That's slope. You know, when slope is negative, it looks like this. When slope is positive, it looks like that. B is the y-intercept. I'm going to create a slider for B. The way you create a slider in Math Whiteboard is when you have an assignment, like a variable equals to a number, in this case, b equals 1, just draw a straight line down from the equal sign like that, and we've got a slider for b. And now I can vary the value of b. Now, looking at the graph, I'm not exactly sure what b, the y-intercept, really represents. because it's supposed to be the y-intercept. Why is the graph moving left and right? Well, let's plot this point. Let's plot 0, comma b. Right. Now, when I plot this point, we can now see what b, the y-intercept, really represents very visually. It's that point where the red line passes through the y-axis. That's the y-intercept. So there's something I say often, and I think it's really important. Learning mathematics is about seeing connections between things. So here we're looking at the relationship between an algebraic expression and a graph. Typically for the math student, the math teacher, the mathematician, we use a primary workspace for doing mathematics. That's the paper and pencil workspace. We also have these complementary or secondary workspaces, like the graphing calculator or a computer, where we're looking at other representations, like maybe we're looking at graphs and tables and animations and diagrams. All of a sudden, we've got these multiple workspaces, and they're all far from each other, and they're disconnected. How do you see the relationship between what you've written on paper with a pencil and what you see on the calculator that you've entered with a keyboard? Those workspaces are far from each other, not just physically, but cognitively. So what we're trying to do with Math Whiteboard is bring together into one workspace all of these mathematical representations, allowing the user to move very fluidly between them, and then hide behind the scenes all the technical stuff. So let me show you another example that really demonstrates this concept in a very powerful way. And the concept I'm talking about is the concept of being able to see connections between mathematical representations. So I'm going to we're going to do a related rates problem here. Let's take a look at a couple of cars. So we'll say, here's one car, and here's another car. And forgive me, I'm not an artist. Those are cars. Here's car A, and this is car B. And we will give length to the road. And we'll say that car A has a constant velocity of maybe 80 miles an hour or 80 kilometers per hour. That's a linear function. It says the location of car A along the x-axis is defined by 80 units of distance per unit time. Car B is maybe a police car that has to accelerate to catch car A. We use a quadratic to describe constant acceleration. So in Math Whiteboard, we have this ability to connect hand-drawn sketches with handwritten mathematics. It's called math sketching. I can turn on math sketching under the More menu. And when I turn on math sketching, I get this little slider that pops up. And on the right-hand side of the slider, there are player controls. When I press the play button, we can see the cars moving across the screen in an animated simulation as described by the math I just wrote on the page. Pretty cool for us, and we're adults. Imagine what happens when you show this to kids in the classroom. Their heads explode. They're really engaged, and they start asking really great mathematics questions, like, can you make the car go faster? Can you make the car bump up and down? They're engaged, and they're seeing a connection between the different representations. So from a very high level pedagogical perspective, what's happening here is that we're making a connection between this very abstract algebraic notation we see on the left and a very concrete example we see on the right, cars driving on the street or driving on the road. That's something we're all familiar with. And that's really important in mathematics, being able to see the connections between that abstract stuff that we're learning in the math classroom and being able to apply it to the real world. That's where the learning of mathematics happens. When we understand the why part of why we're learning mathematics, then we can have an appreciation for why it's important. So that's from a high-level pedagogical perspective. But from a very practical perspective, this is a related rates problem. And with related rates problems, they typically show up on standardized exams, and they come with a couple of questions. The first question might be, at what point in time does something happen? And then the next question might be, at what distance does something happen, or at what location? So the questions here are, when does car B overtake car A? And when we run the simulation again, we can see that happens just about there. Well, that's a math observation, not a math answer. We want to get the math answer. How do we get the math answer? Well, there's a couple of different ways to do that. If you're a math teacher, you know that we can set these equations equal. This is a system of equations, and we can set the equations equal to each other and solve, and that will give us the intersection points. And of course, underneath the hood here with Math Whiteboard, we've got that very powerful computer algebra system that you saw me use before, and it will do that for us. If we want to set the equations equal to each other and solve, we can get the intersection points. Another way to solve this is through exploring the graphs and then trying to come up with a hypothesis for what the solutions might be, and then testing the hypothesis and then proving it. Let's do it that way. So what we're going to do is we're going to graph these functions, and I'm going to, with my fingers, pinch and zoom. Oh, by the way, I graphed those two functions with just one swoop through both functions. And now we can pinch and zoom the graph, and we can look at the graph, and now maybe we can make some hypotheses about what's happening with the system. We can see that there's an intersection point at the origin. That's where the cars start. And then there's an intersection point out there in the quadrant. That's where the quadratic overtakes the linear, but it's where we hypothesize that car B should overtake car A. And we can see that happens at about 8 units of time and about 650 units of distance, right? So that's our hypothesis. When time equals 8, the car should be at about 650 units of distance. So let's test the hypothesis by running the simulation again. And all I'm going to do is bring the slider over here and move the T over to 8. And we can see that the cars are at about the same location. And we're just eyeballing the simulation. We're eyeballing the graph. We haven't proven anything yet. We just know we're on the right track. Let's prove it. The way we prove things in algebra is through substitution. So I will substitute into our functions here the value of our hypothesis when time equals 8 to see if the location of car A along the x-axis is what we think it might be from the graph, 650 units of distance. 640, that's pretty close. If B sub x is also 640, then we have proven the hypothesis. Pretty cool. So I love this example because it demonstrates the power of having multiple representations in one workspace, and everything is connected. You've got the algebraic representation, you have a simulation, you have a solution, you have a graph. You could look at a table of values if you want to, and everything is connected. So when the student said, can you make the car go faster? Well, we can change the 80 miles an hour to 90 miles an hour. And look, all of a sudden, the graph changes. The pointer intersection moves over here. The solutions change as well. So let me pause for one moment and see if there are any comments or questions that you might have. Dr. Narjeet, have you seen any interesting questions that showed up in the chat, or do you have any questions yourself?
Yes, this seems pretty easy, and it seems really interesting. I mean, with one stroke or one digit, the entire graph is changing. You do not even have to rewrite any formula. That is something really amazing. So many of the educators want to learn about how this can be helpful for smaller kids, for primary school children.
That's a great question, and let me jump. That's actually a very good leading question, because the next thing I'd like to show you is some functionality that can be applied at the lower grade levels. So thank you for over here in the United States for folks who play American football, and that would be called leading the catcher. When you throw the ball out in front of the catcher as he's running, you're leading the receiver.
Don, there is somebody asking. One of them wants to know if we can teach geometry also with this bow.
Oh, that's a great question. And in the interest of full disclosure, we do not do a lot with geometry. We do the algebraic side of geometry, and again, there's plenty of algebra in geometry. So, for example, you might have. I apologize for going back down here. In geometry, you might be looking at manipulations of trigonometric functions and transformations of trig functions. We do that side of geometry, but on the construction side, not as much yet. So stay tuned. We're always expanding in terms of breadth as well as depth in the functionality for Math Whiteboard. We hope in the future to have much more coverage across all the grade levels. But we're filling it in, and so stay tuned. But a really good question as well. Thank you.
That's great. That's great. So if you want to learn more about geometry, you have to keep in touch with either Don or his Math Whiteboard, because that is how you're going to learn more. And he's going to add more amazing features in the days to come to this Math Whiteboard. So definitely, and somebody wants to know for teaching fractions also. They want to learn everything today. They want to learn how to teach fractions through this, and they want to learn, how to go about for, yes, smaller children first.
Oh, that's great. Similar to the first question that you had asked about teaching at the lower grade levels, uh, I'm going to show you something that applies, I think, at the lower grade levels. Uh, just again, in the interest of full disclosure, we don't do a lot at the lower grade levels in terms of what you're familiar with in terms of manipulatives and so forth. But you'll see where we're going, and you'll see a couple of innovative things in the next thing that I'm showing you. So it can be applied at the lower grade levels, not everywhere. And as with every tool that you're using to teach and learn mathematics, all the supplementals that you're using, sometimes you use one tool for one area because it's really good at that, and another tool while teaching another topic. And I think hopefully the next thing I show you will wet your whistle, so to speak, on some of the possibilities. And in fact, I'm about to show you something that I think you probably have not seen anywhere else. I think it's very unique to Math Whiteboard, and I'd love to get any feedback that folks have on this bit of functionality. So let me show you what it's all about. Let me show you this next bit of functionality. And oh, by the way, were there another couple of questions, or is that it for the moment, Norji?
Oh, okay, all right.
Okay, great. Here we go. So this bit of functionality I think is pretty interesting because it does a few things. It helps very visually as students are working through problems, and it also perhaps gives students a little bit more ownership of what they're doing as they're solving a problem. Let me show you what it is. We have this ability within Math Whiteboard to test for equivalences on a page. And what do I mean by that? Well, let me show you. So under the More menu, I can turn on Highlight Equivalence. And when I write anything on the page, it will be highlighted the same color as anything else on the page that is equivalent. So for example, 3 and 2 are not equivalent. So they're color-coded differently. And 4 is not equivalent to 3 or 2. So again, it is color-coded different than 2 and 3. But 6 over 3 is equivalent to 2, so it's color-coded the same as 2. And 4 over 2 is equivalent to 2. So again, it's color-coded the same as 2. You can imagine using this at the lower grade levels where we're looking at equivalent fractions and equivalent decimals and so forth. You might even look at it in terms of maybe playing a bit of a game. Let's play a little bit of a game here. So let's say, for example, I have some other numbers written on the page. Maybe we have 5 and we have 10 over 2 and 20 over 4. So of course the point of this game is, and I'm sure you can guess it, we want to play a matching game where we want to match up equivalent fractions. So let's do that. So 10 over 2 and 2, maybe they go together because they both have 2's in them, and then maybe 4 over 2 should be over here as well. And then 20 over 4, I don't know where that goes. Well, let's put that down here too. And then 5, holy cow, I'm not sure how that fits into the picture. And then 6 over 3, let's put 6 over 3 and 5 together. And then we can turn on highlight equivalence here, and we can now see, did we do a matching correctly? Oh man, did I do a bad job here? Oh, by the way, we want this 20 over 4 to be 20 over 4. That's a better 20 over 4. Oh, okay. Oh man, I did a bad job on this matching, huh? It's supposed to be the 4 over 2 and 6 over 3. So and then 4 over 2, and what did we do wrong and what did we do right? I guess those are the questions that you're asking when you're playing these kinds of matching games. But you can imagine using this color coding at the lower grade levels while doing equivalent fractions and equivalent decimals. This can also be applied at the higher grade levels where we're looking at things like equivalent algebraic expressions. So for example, a plus b and b plus a are equivalent. So they're color-coded the same, but a minus b and b minus a are not equivalent, so they're color-coded differently. And then a times b and b times a are equivalent, so they're color-coded the same. And then a over b and b over a are not equivalent, so they're color-coded differently. So far, we're looking at numeric equivalences and simple algebraic equivalences. This can also be applied at the higher grade levels where this might be in geometry or in pre-calculus or calculus, where we're looking at trigonometric identities. So for example, tangent of theta is not equivalent to sine of theta. So these are color-coded differently. But sine of theta over cosine of theta is equivalent to tangent of theta. So now it is color-coded the same. Pretty cool and applicable across lots of grade levels. But perhaps the most powerful way in which to use this color coding technology is in step-by-step problems. So for example, if we had this math expression, 2x plus 3y equals 4, and let's say we wanted to solve for x here, what would we do? The first step we might do is move the plus 3y over to the other side. So let's do that. So the first step here is we're moving plus 3y over. So the first step would be 2x equals 4, and then plus 3y, right? Hey, wait a second. It's not color-coded the same as the first step. I must have done something wrong, because every step in a step-by-step problem should be equivalent and algebraically equivalent to any other step. So I've gotten that immediate feedback indicating, oh, I made a mistake. What did I do wrong? So now I can look at that one step and try to discern exactly what I've done wrong. And of course, we all know that I forgot to change the sign when I moved the plus 3y over across the equal sign. So we can change that plus to a minus. And now it's color-coded. The first step there is color-coded the same as the original expression. So now I know that I've done the calculation correctly for that first step, and I can continue on. I have the confidence to continue on to the next step. So the next step, of course, is x equals 4 minus 3y over 2. Right, so we've solved for x, and it's color-coded the same, so we know now that we've correctly solved the problem. Of course, what we're doing here is we're giving that immediate feedback to the students. And, we've only got a couple of steps here, but oftentimes in algebra, and as you proceed through your mathematics learning, these step-by-step problems can grow in length to 5 or 10 or even more steps. And for students who are struggling with mathematics, it can be very discouraging to get to the 5th or the 10th step in a step-by-step problem, only to realize I got it wrong. What did I do? Where did I make my mistake? I've invested so much time solving this thing, and I got it wrong. And again, it can be very disheartening and discouraging to students, especially those who are struggling with mathematics. Let me show you another example, and you were asking about lower grade levels. This can also be applied when we're looking at order of operations. So for example, 2 minus 3 times 2 minus 3, right? If we were to solve this, what would we do? Well, the first thing we might do is we might multiply the 3 across the parentheses, right? So this might be, the first step here might be 2 minus 3. Oh, no, we want that's 3 times 2. That should be 6. And then 3 times 3, that's minus 9, right? Hey, wait a second. I must have done something wrong. It's not color-coded the same as the first statement. What did I do? Oh, you know what? We forgot to multiply negative 3 times negative 3. That is a plus 9. Right? Okay, cool. It's the same color as the original statement, so I must have done it correctly. Let's move on. So the next step here must be 2 minus, and then 6 plus 9, that's 15, right? 15. Hey, wait a second. That's not color-coded the same either. Oh, I must have done something wrong again. What did I do? Oh, it's minus 6 plus 9. Oh, so that's a plus 3. Okay. It's color-coded the same. Cool. And now I know that 2 plus 3, that's 5. Okay, great. I've gotten to the solution correctly because every step is color-coded the same. Now, of course, as happens with everything in math, there's multiple ways to solve every problem. So this could have been done a different way. So this could be 2 minus 3 times minus 1 here. And now, of course, it's color-coded the same, so we did that correctly. And then the next step here is 2 minus 3 times minus 1. That's got to be minus 3, right? Oh, wait a second. It's not color-coded the same. I must have done something wrong. Oh, it's minus 3 times minus 1. That's got to be a plus 3 in the middle. Okay, cool. And then I know, of course, 2 plus 3 is 5. So I think a pretty cool bit of functionality for students to, either check their work as they're working through it, or for students to be getting that immediate feedback as they're working through problems. There's still a lot more I'd like to show, but if there are any questions, please let me know.
Right now, we do not have any, but they are getting amazed at how this color coding is working.
Oh, great.
They're really like the concept of color coding, because now I know that I will get my student hooked on, and the student also instantly knows that because the colors are not matching, there is something seriously wrong with the steps that I have had and the steps that I have taken before reaching this. I don't know how to talk math because I am an English teacher and I'm a PhD English. I do not know actually how to talk math, but yes, the way they are responding and the comments that are coming, they're really amazed at this color coding concept for sure. And this make I'm sure this is going to make things a lot easier for our teachers to explain the concepts and everything in the class to get the child interested in mathematics. I was never. Maybe I did not have a math board at that time. I would have done something really great in mathematics as well.
Well, maybe we can convert you to a math person.
I will definitely try now. Definitely. Even if I have to start with 2 plus 2 is equal to 4, I'll definitely try that. This is going to be math magic for everybody.
Awesome. Well, let me continue on and show you some more bits of functionality. There's a lot more that Math Whiteboard does. One of the most useful and powerful bits of functionality, especially now at this time that we find ourselves in with online and distance learning being pervasive. It's everywhere now, especially with the pandemic, having to do online learning. And even if you go back into the classroom, you may find yourself in circumstances where you have to socially distance, or you have to stay 6 feet from each other, where maybe you don't want to share the same piece of paper. Every Math Whiteboard can be shared. So every Math Whiteboard has a unique URL. You can see that up at the top of the page here. When I click on the copy link button, that will copy the URL to my clipboard, and then I can paste that URL into an email to a student, or a course webpage, or like a learning management system, or a Google Classroom, or a Microsoft Teams chat or something. I'm just going to click on copy link here. It's going to copy it to my clipboard. I can then go over into my other Math Whiteboard I have on the page here. This represents maybe a student on their computer. So the browser window I have on the right-hand side is the teacher, and the browser on the left-hand side might be the student. So I'm just pasting that URL into the student's browser on the left-hand side. And again, these represent two different users on two different computers, not necessarily in the same room. So when the teacher writes something on her screen on the right, on her computer on the right, as I'm going to do right now, whoops, like y equals x, for example, you can see it's displayed on the student's computer in real time. And it's not just displayed on the student's computer, it is alive. It's a shared collaborative page. So all the tools that I've shown you so far, all the mathematics tools, are available. So I wrote that originally on the right-hand side. I'm going to edit it on the left-hand side here. So maybe we change that to slope-intercept form. And like I said, all of those bits of functionality are available. So we can put graphs on the page. We can put sliders on the page. We can make assignments. We can use color coding. Everything is, it's a shared collaborative page here. So when the user on the left-hand side makes a change, the user on the right-hand side can see that change. Now, one of the things that we've learned after having released this just a few months ago is that mathematics teachers, are very creative people, and they've been using a bit of functionality in Math Whiteboard that we did not expect to be used this way, but we think it's a really cool use of the functionality. So every Math Whiteboard can have multiple pages. I've just opened up the slider from the left-hand side over here. And you can see there's the page there at the top. I can add new blank pages by just clicking the plus button, or I can make copies of this. I can hit Control-C on that page and then hit Control-V a few times. And the thing that the math teachers have been doing that we found is very creative is that they're assigning groups of students to each of these pages. So, for example, they might assign to page 2, group 2, or student 2. And then maybe on slide 3, they assign group 3. And then on slide 4, they assign group 4. So let's just say, for example, the student on the left-hand side here is on slide 3. Maybe this is 2 students. Maybe this is Mary and Billy working together. So maybe Mary and Billy, they turn on their pen color to green. So Mary's a very diligent student, so she writes y equals x on the page. She's doing more math on the page. And the teacher on the right-hand side can see that that slide was updated in real time. So you can see the green over there on the slide. And then maybe Billy is kind of goofing off. He's just writing smiley faces on the page over here. So the teacher again can see in real time that there's some smiley faces showing up on the page. So it's a way in which teachers can have groups of students working collaboratively, while the teacher can also view what they're doing and also, if need be, collaborate on those pages along with the students. Pretty cool bit of functionality. So I'm going to show you a few more things here that are interesting for Math Whiteboard. The next bit of functionality I'm going to share with you is a teacher favorite. Everyone loves this bit of functionality because it allows the mathematics teacher to use or leverage those resources that they've been gathering for years in the form of PDF files. So I am on the left-hand side here going to open up a folder, and I've got some worksheets over here. This is a folder with 9 or 10 PDF files. And your average math teacher might have hundreds of PDF files, worksheets that they hand out during the school year. I'm just going to open up one of these, maybe solving systems of equations by substitution here. So this just looks like any other PDF file. I just open it up in Acrobat Reader. But you can take any PDF file and you can drag and drop that PDF file right into Math Whiteboard, and it becomes the background for your Math Whiteboard, upon which you can do all of your Math Whiteboard's mathematics. So I can write math on the page, I can put graphs on the page, I can do calculations, and if I want to, I could just annotate the page. So I could just turn on my draw pen, and maybe we're going to solve this problem here, and we're going to work through it, and then we get down to the bottom here, and we put an answer on the page, and then maybe I change my pen color, and I'm going to work on this problem, and we've got some, we work it through, and then we come up with our solution x, y is equal to something. All of a sudden what happened was that our static PDF file that we printed out on paper and handed out to the kids physically becomes a live, interactive, dynamic, collaborative web page that can be shared interactively in real time with our students or between students. And by the way, if you want to, you don't have to use all the math stuff. You could just use this as an annotation tool for PDF files. In fact, it does not have to be a math worksheet. It could be a history worksheet or an English worksheet for you, Dr. Narji, or it could be a chemistry or physics worksheet as well. And we're just marking it up with the draw pen. And by the way, this is a multi-page PDF file, so each of these pages was imported as a separate page in Math Whiteboard. All right, so well, that's a favorite. Oh yes, go ahead.
This is amazing. This is amazing, Dawn. Something in the entire workshop, I've been looking for something that we can directly do with the PDFs or with the assignments, or annotating is something that is really amazing. I wasn't expecting this feature to be coming up. Actually, I thought it is only a whiteboard, and then we are going to do formulas, and then we're going to write equations, and so on and so forth. But we can annotate, and it is all real time, something which is happening real time. I think that is one of the most awesome features for the teachers. They can annotate, and it's something that they can do in real time as well. Collaboration, as we always talk about, collaboration is something that is happening these days all around. And if the teachers can do a live collaboration with the students, and you can check in the real time what all they are doing, I think that is one of the most amazing features. And yes, this session video will be available for later use as well. You can revisit the session if you have missed a part of it, and you can revisit the session, though we are still in the mid of the session. But yes, because you have asked, you can always visit the session later. You just have to subscribe to the YouTube channel where you are watching the video right now, and it will be available there. And later on, you can go and do anything. So yes, somebody asking this annotation feature for any other subject also. I think yes, Don answered that it is available for all the subjects, and he really mentioned me with English. So I'm very happy that if I'm able to open a math whiteboard, something really relative is going to happen to me if I am able to open my own worksheet and start working on that. So that's amazing. Yes, it works on this features. It works on other subjects also, but because this is a very dedicated a whiteboard, the name itself suggests it is a dedicated math whiteboard. So we will love to discover so many things, awesome things that Dawn has been doing with mathematic formulas and things like that. Okay, then somebody's asking, can they do this with angles? How to create or make angles, and to show right angle, acute, if I am speaking it right, etc., etc., to the children. How to explain the concept of angles to the children through this whiteboard?
Yeah, that's a great question. And again, similar to the earlier question about geometry, we don't do a lot of geometry yet. You can do the algebraic side. So if you wanted to do things in graphs and plot graphs of lines that might have acute or right angles, you can certainly do that. In fact, you can use the sliders to manipulate the graphs and show how the angles change. But from a specific geometry kind of construction perspective, we don't do that yet. So stay tuned as we add more functionality, especially for other mathematics subject areas.
So yeah, as of now, do somebody's asking if we need to have any other device also, like an electric pen or a Wacom or a pen tab, to do such kind of a thing, to make this happen.
That is a great question, and that's, again, a great leading question, because the next thing I'd like to show you is the functionality that enables this to work on any type of device, even those devices that do not have touchscreens, and that is our keyboard and mouse-based interface, which makes using this just as simple and easy as I've been using it so far with the stylus. So let me jump over and show you that bit of functionality. Oh, but one last thing here, I wanted to comment on the PDF import here. As you mentioned, this can be any PDF file, so it doesn't have to just be a mathematics PDF file. It could be a history PDF file or any subject area. It's just a PDF file, so it's essentially just an image. In fact, one of the things that we found teachers doing with this import functionality is when you're in an online environment and your student has a question about a particular problem that they're working on, the student may, during a regular class period, if they were in the classroom physically with you, they might raise their hand and say, "Hey, teacher, I have a question on this math problem." And then you walk over to the desk and you work, you look at what they're doing. In the virtual world, what happens is that the student raises a hand and says, "Teacher, I have a problem." And then the teacher says, "Well, take a picture of the problem with your phone and then email it or text it to me." And then you, the teacher, bring it up on your computer. You have to find some program to use to annotate it. And then you email it or text it back to your student. With Math Whiteboard, the student could just take a picture with their phone and then drag and drop the picture, because it does not have to just be PDF files. It could be image files. So on a phone, you can take a picture with your phone and then drag and drop the image into the Math Whiteboard. And then you can give the URL of the Math Whiteboard to your teacher, and then your teacher can annotate it in real time as you're looking at it as well.
So yeah, with touch screen and pen tabs, it gets easier. But yes, you can use it with your mouse and your desktops, your laptops as well. It really, the functionalities are there, and then you can go and explore as many as you want. So right here we are in the next part of the session.
Yes, let me show you how the keyboard and mouse interface works. As I mentioned earlier, this works on any type of device. So if you're using a device where you only have a keyboard and a mouse and you do not have a touchscreen, it works just as effectively. So let me show you how that works. So far we've been using the draw pen up here, and we've been using the math writing pen up there. And you use the draw pen to draw things, like maybe a smiley face. Or you use the math writing pen to write math. So I might write 2 plus 2, right? And that gets recognized as math. You'll notice the smiley face didn't get recognized. In fact, if I were to use the math pen to write a smiley face, that doesn't really make much sense in math. And Fluid Math tried to recognize it. I guess it recognized it as a 0, but again, that doesn't really make much sense in math. In the middle, we have this mode called math typing. So when I turn on the math typing mode, I can type math onto the page. So for example, I'm going to turn off the highlight equivalents here just for a moment. So for example, I can use my physical keyboard to type math on the page. I'm going to type y equals ax squared plus bx plus c. Now, I use my physical keyboard on my laptop to type this, but not everyone knows how to use a physical keyboard on a laptop to type math. So for example, how do you type x squared? I know how to do it because I know the control sequence, but not everyone knows how to do that. Most often we're using these calculator style keyboards. And we have a calculator keyboard on the screen here. We call it, it's really a virtual keyboard. So when I begin to type math here, the little calculator keyboard is displayed, and I can pick and peck at this keyboard here. So I can say, with my mouse, select y equals x squared. And you can see that y equals x squared is displayed here on the screen. Now, just a hint for folks who might begin using Math Whiteboard, you've seen me create graphs with the swooping gesture. So, you might think, I can just grab a math expression and swoop and it'll show a graph. That's not the case. You'll want to go to the Insert menu and select Graph, and that will put an empty graph on the page. And then you can drag and drop your math expressions right into the empty graph area, and those math expressions will graph automatically. And the free variables in this math expression, A, B, and C, are clickable. So I can click on A, and I can click on B, and I can click on C, and now those give me sliders to manipulate dynamically the values of A, B, and C. So we can change the value of A and B and so forth. So everything I've done so far with the stylus and my fingers on my touchscreen can be done just as effectively with a keyboard and a mouse. In fact, sometimes you may want to use the keyboard and the mouse because it creates a much more visually appealing math whiteboard than if you have your big, ugly handwriting on the page. So for example, if I were to write some math on the page, maybe it doesn't look so good, and it takes up a lot of space. So underneath, you can always convert your handwritten math into typeset math. So underneath your handwriting is a button. When I click on that button, my handwriting will go away, and I'll be left with just a more pretty print typeset version of the math expression. So I'm going to click that button, and now I'm left with just the more well-formatted math expression. I'll get rid of these arrows. And by the way, I can graph that. I can drag and drop that right into the graph area here. Or if I wanted to, I can put another graph on the page. Another way to put another blank graph on the page is just draw a big plus, and that will put a blank graph in the graph area or on the Math Whiteboard. And I can, again, drag and drop that math expression. Now, you'll notice that there's one B slider, but there's a couple of math expressions that include the B variable. So when I change the slider for B, you can see everything associated with B on the page updates dynamically. But let's for the moment get rid of this math expression over here. Another cool bit of functionality here is that we can add text boxes. Now, text boxes seem pretty simple. Ours are a little more rich than others. Let's see. We're going to turn on text box here, and of course, I can put some instructions on the page. And if we're going to create a more well-formatted page that we would share with our students, we might include some instructions on the page. So I'm going to put some instructions here. Play with the sliders to understand the Okay, those might be the instructions we include for our students. But these text boxes are really rich. I can do some pretty cool things. One of those things I can do is I can embed a YouTube video. So I have queued up in this browser tab over here. I have this is a YouTube video on using quadratic formulas. And so back in my Math Whiteboard, I can click on the edit button within that text box, and I can click on insert. I can click on media, and then now I can enter an embed code. Now the embed code is something you can get from the YouTube video. I'll go back to that YouTube video, just hit tab here, and when you click on the share button under a YouTube video, you can get the different share. You can get like the link for the YouTube video. or you can get the embed code. I'm going to get the embed code here. I'm going to click it. I'm going to copy it. So I just copied the embed code. Now I'm going to go back to my Math Whiteboard, and I'm going to paste that embed code right into my text box. And now all of a sudden I have a YouTube video built embedded right into my Math Whiteboard. And by the way, it's live in the Math Whiteboard. It plays there live. Whoop, maybe you can hear that. So this is kind of keeping in the spirit of Math Whiteboard, where, as I mentioned early on, we want to keep the student in one workspace. As soon as the student starts moving between browser tabs and browser windows and devices, all of a sudden you start to lose the connections, or you start to not being able to see the connections or the relationships between the various mathematical representations. We want to keep the students in one workspace and have all of those mathematical representations together in one workspace. So, yes, go ahead.
Yeah, Mala ma'am has a question. Mala ma'am here is our co-leader, and she has a question. And before Mala ma'am can put up a question, there is a small thing. Right, I love this concept. Whenever I see videos and audios being embedded into the live worksheets and everything, that feature is something which is amazing for me, because that is something that goes real time actually. So yeah, uh, is it, I mean, can we share the online worksheets also? For example, I create a worksheet here. I create formulas. I write formulas and I write all the steps how to come to a conclusion or something. Can that PDF or a picture of the screen, can that be shared with the students later on so that they can revise what was done in the class?
Yes, that's a great question. I'm going to give you a few different answers. And the actual answer will be E, all of the above. So I'm going to give you the multiple choice, but the true answer is that you can do this in multiple different ways. The first way that you can share these pages, as I mentioned earlier, is that you can copy this link. You can click on copy link, and I'll do that right now. I'll just show you how that's done. I clicked on copy link, and now I'm going to paste that link into this browser window on the left-hand side here. So now I'm sharing it, but I'm sharing the same page with the students that I created. So as you've seen so far, now that I've shared this page with the students, when a student makes a change on the page, it updates my original. And maybe I don't want to update the original. Maybe I want to have a copy of it so that I can use it a couple more times. So one of the things you can do, and you saw me pull out this slider before, I'm going to create, on the left-hand side, I'm just going to create a completely new Math Whiteboard. These are not the same Math Whiteboard. They have two different URLs up here. On the right-hand side, I'm going to make a copy of this slide. So I can hit Control-C on that slide on the right-hand side here. And then on the left-hand side, I can click on that slide there. I can paste Control-V. And now I have a copy of that slide, but in a new Math Whiteboard. So essentially what we're doing here is, you've got the original on the right-hand side, and you've got a copy on the left-hand side, and then you can take that copy and maybe you can share that with your students. So your original is not going to be touched by your students, but the copy can be shared between students. And you can do this any number of times that you want to. The third answer to your question is, the third answer to your question is that you can print any of these Math Whiteboard pages to PDF. So when I click on print here, and I print the PDF, this will print this Math Whiteboard. So if you need a hard copy of that Math Whiteboard that you created, and it's taking a little bit of time to render in my browser here, but the idea is that you can print this out to a PDF file and then share it if you'd like to. And then the fourth answer to the question is that if you really need to save these things and you need to share them, you can see it just rendered. You can use another system. As I mentioned in the beginning, this is a free system, Math Whiteboard. Our company's actually been in business for a little bit more than 10 years, and we have another product called Fluid Math. And Fluid Math is a subscription-based system with logins and so forth, and accounts. And Fluid Math includes as one of its pieces, the Math Whiteboard. So if you really needed to save these things and you wanted to hand them out to students automatically, that's where the Fluid Math system comes into play. So the Fluid Math system allows you, with an account, you can save these documents. And you can also share to Math Whiteboard, which means that if you have a Fluid Math account and your students do not have Fluid Math accounts, you can have you can keep all of your documents in Fluid Math. And then there's a share button that allows you to share out to Math Whiteboard.
Oh, that's very helpful. That's very helpful. Also, one of our maths teacher who's already been using Math Whiteboard, he wants to ask whether when we share the whiteboard link to the students, is there any time limit on editing? I mean, they can access and edit it within 1 week or 1 month or something like that.
That's a really great question. So at the moment, we do not delete or remove any of the Math Whiteboards. So they kind of have been living since the day we launched this. But what we've noticed is that a lot of folks are creating Math Whiteboards and not coming back and revisiting them. And that's fine. And that's the intention for Math Whiteboard. It's sort of it's a transient system, a transient document that you're using. And maybe you use it for a little bit of time, maybe a day or a couple of weeks, and then you move on with your subjects. So at some point in the future, we may remove some of the Math Whiteboards that have not been used in a while. So they may expire after a bit of time, but we do recognize that math teachers probably want to maybe create some of these examples and then use them in class a few days later. So we probably will not be deleting things for a while. Or we'll give them an expiration time that's a pretty good amount of time. So maybe a few weeks or a couple of months before things expire. And it all depends on how things happen in our database, because these Math Whiteboards take up a lot of space, and lots of people are creating them. So at some point in the future, we may make them expire. At the moment, they don't.
All right. At the moment, we are all free to create as many boards as we want. So maybe in the future we are going to have a limit to the number, but as of now we can create as many. And all the math teachers must grab this opportunity. This looks awesome. To a non-math person like me, I'm getting intrigued. I really want to try every feature here. So it must be really interesting for the math teachers to try on. So please go and try, explore. I am sure this is going to really benefit you in your classrooms, teaching, making the concepts clear to the children, so on and so forth. So yeah, Mala ma'am, please go on.
Mr. John, I have a question to you. Suppose if I'm typing a question paper in Word and I want to incorporate the graph from Math Whiteboard to the Word, is there an option?
That's a great question. Actually, that's a really good question. I'm going to create a new Math Whiteboard here just really quickly. So there's a couple of things you can do. The first thing that you might be interested in doing is taking your math expression and putting it in Word. So for example, and this is one of the challenges that I think that math teachers face, is that the equation editors in the word processing systems are less efficient than writing mathematics. So for example, if you had a math expression that looked like this, so let's do y equals 1 plus, let's do 1 plus 2 over, I'm trying to create something here that would be a pain in the neck to have to type in with the equation editor in a word processor. So this might be a pain in the neck to have to type in using the equation editor in a word processor, because if you're not familiar with those equation editors, it's kind of difficult when you've got multiple layers and levels and spatial relationships between all of your symbols in your math expression. In Math Whiteboard, you can right-click on any math expression, and you can get one of multiple typesetting languages. The one that works pretty well with Microsoft Word is Presentation MathML. So when I select Presentation MathML, and then I open up a Microsoft Word document, I have a Microsoft Word document open here, and I hit Control-V, I all of a sudden get a typeset version of that math expression in Microsoft Word. And by the way, it is editable here, so I can cursor through and change things. So if I wanted to change the denominator from a plus b squared to a plus 3 squared, I can type that. Now with graphs, It's a little bit different. So let's say, for example, we have y equals x squared, and I want to graph that. So the thing you can do in Windows is you can use the snipping tool. I think I have a snipping tool here. I can use the snipping tool, and then I can set this to rectangular mode and click on new, and then I can just clip this as an image here if I want to, like that. And then I can go to my Microsoft Word document and I can paste, hit Control V, and that will paste that into my Microsoft Word document. I hope that answers your question, Malalam.
Yeah, Dawn, somebody wants you to show this again. They didn't get the step.
Oh, the graphing or the math expression?
Right, graphing, yes.
Oh, okay. Let me show you that again. So we'll just start from scratch again. So in Windows, there's a tool called the Snipping Tool. So I have it pinned to my quick launch bar down here. But if you just go to the Windows search feature at the bottom here and you type in snipping, you get the Snipping Tool. It's built into Windows 10, I believe. And you just click on Snipping Tool. That will open up the Snipping Tool, and you can set the mode to be either a freeform snip, a rectangle, or a couple different modes. I set mine to rectangle because I just want to grab a rectangular area. Click on New, and then I can just highlight that one area of the graph. That'll copy that to my clipboard, and then when I go to Microsoft Word, I'll delete that here. And what I'll do is I have my Microsoft Word pre-zoomed. I'll zoom in a little bit. If I hit Control V here, then that graph is now pasted in as an image into my Microsoft Word document.
Well, that's amazing. That makes, I think that makes the work of the math teachers actually easy. And, I know that math teachers have been looking for some tool of this kind. Not only explanation, but also I think the curating of the question paper is going to get really easy with this. Actually, so Reshma wants to say that with the embedding images of the graph, any changes made to the base equation would not change the graph, right? As they are no more linked to each other.
That is correct. When you paste it into a different program, there's no link between what we've done in Math Whiteboard and that other program.
So once it is pasted as a picture. So no linking existing between them, right?
That's correct.
So somebody else wants to get into, they're all getting very excited with the question paper part because this is something that is really a task for the math teachers. So can we type the maths question paper in Math Whiteboard and then convert to PDF? And when we convert to PDF, it is all typeset?
Yeah, so what you can do is you can print the PDF. So from the print menu, you can select print, and then that will print this Math Whiteboard to a PDF file. So we don't yet export necessarily the document to an editable PDF, but if I just select Save as PDF here in my print dialog box, then we'll get, and I click Save, that will save this Math Whiteboard as a PDF document. So if I need a hard copy of the document, of course, it loads in that way.
So really, I think this is going to get the teachers really, it's a huge benefit for the teachers that they can simply pen tab the entire question paper here, and when they want to convert it into a PDF, that is a typeset PDF for them, and that can be converted into a question paper. So that is really pretty easy, and that is really very, very good option to try. So all the teachers are definitely going to try that. And I know we are well beyond 1 hour session, and I have no more questions now coming. So folks, I have pasted the link for the feedback form. I'm looking forward to the feedback, and I'm sure we are going to have amazing feedback for the session today. As I said earlier also, even if for a non-math background kind of a teacher, it is getting me all, I'm getting all inquisitive to try it. Definitely math teachers are going to benefit from it, and they are going to benefit big time. So thank you so much, Don. I know it is the timings, etc., weren't all that suitable for your side, but yes, thank you so much for coming, and I'm sure my educators, my members, the teachers, my fraternity, we are all going to really benefit from what we have seen today. And I'm getting amazing compliments. They're saying that it was an amazing session, and they really want to thank you. So I, convey all their thanks to you, Don. Thank you for coming, and thank you for taking up this session. Thank you so much. Thank you.
Awesome. My pleasure. Thank you so much again for inviting me. And again, my prayers and their thoughts go out to you as you're going through this very trying time with COVID. So please
Yes,
stay healthy.
we need prayers. We need prayers, and I hope that you keep healthy and you are taking care of yourself. Please take care of yourself, and keep attending the PD sessions like you did today. Today was the highest number of educators who joined ever in the. I mean, I began my GEG a month and a half back, and today I have had the highest number of members who have joined, and even non-members. So thank you so much, Don. I am really looking forward to sessions which are really going to be beneficial. And next week we are going to have a session on book creator, which is another important and an amazing tool to create projects, to make magazines, to get homework assignments, so many things that you can do. I mean, the possibilities are endless. So see you next week, and we are going to see you at the same time, 4:30. Today we couldn't get 4:30 because of course, because our guest um, really had to wake up really, really early for this session also. But yes, for the timings weren't suitable. So thank you so much for joining, and thank you so much for being with us. With that, I end my broadcast. Good night, everybody. Good night.
Good
Be
night.
safe.
Thank you.